All right, let's start looking at practice exam number 3-1. And we'll start by doing problem number 1. So my goal here is just to go through and talk about how I would think about the problems and hopefully help you as you're thinking about ways to approach these problems as you prepare for exam number 3. So as we talked about when you were thinking about exam number 2, you should look at each problem and figure out what type of problem it is. So problem number 1, I hope it's clear, this is a predictive products problem. You don't have to write out the mechanism. You can if you want, but it's simply, what are we going to make given all these reaction conditions? And like I said when we were talking about this in class, it's very important to look at what each reagent tells you about what's going to happen. So before we start writing out what sort of products we're going to get, let's write what these reagents are telling us. Right? Some reagents are going to tell us more than others. So if we look at the first one, we're starting with a nitrile. All right, we do acid and water. Let's not worry too much about that reaction right now. I think the key reaction here is this one with SOCl2. SOCl2 only does one thing. It converts a carboxylic acid into an acid chloride. So I think that's a really important point for this reagent, is that we know we're going to have some sort of carboxylic acid after the first step, and then using SOCl2, we're going to make an acid chloride at the end of the second step. Right? That tells us what the product is for the first step, a carboxylic acid. Very helpful. All right? And then it tells us that for the third step, we're going to add an amine to an acid chloride. Right? So this problem is based on carboxylic acid derivative reactions. Okay? So let's just work this one out. All right? Recognizing the SOCl2, I think we're in very good shape to figure out what's going to happen in this problem. All right? So we have a nitrile, acid and water, and heat. That's going to turn the nitrile into a carboxylic acid. We already knew that from thinking about how SOCl2 reacts. So the first compound we're going to make, and again, let's not lose any carbons. Be clear, there are 6 carbons that we have to worry about as we do this. Right? It's very easy to lose one of those carbons. Right? So again, 1, 2, 3, 4, 5, 6. We make a carboxylic acid. Now we add SOCl2. Turn the carboxylic acid into an acid chloride. And now we add 2 equivalents of a secondary amine. And again, hopefully we're very clear on what happens when we have reactions of acid chlorides. They're going to make other carboxylic acid derivatives. An acid chloride plus an amine is going to give us an amide. And the reason that we have 2 around is that we have to have 1 act as the nucleophile and then 1 act as a base so that we get this amide product. Plus the conjugate acid and Cl minus. All right, so the product that we're looking for here is that amide. Okay. And again, knowing SOCl2 is the key to doing this problem and doing it correctly. Now move to the second problem. Right, we have a cyclic ester. Right, so we're thinking about ester reactions here. Right, and we have acid, water, heat, same conditions as the one we did up top. PCC. Right, that's very important. Right, PCC. We know that's going to take some sort of alcohol, right? So we're going to have primary alcohol going to an aldehyde, or we're going to have a secondary alcohol going to a ketone. All right, those are the only reactions that PCC does, oxidation reaction. And we have a Wittig reaction. Right? We know we're going to make a carbonyl here, and remember, when we have this Wittig reaction, that's going to take one of these things up here, and it's going to turn it, right, so either of these, it's going to turn it into an alkene. Okay? So we now know carbonyl is going to go to an alkene, and now we have an alkene plus HCl. Right? We know that we're going to add HCl across the alkene, so this is going to make an alkyl chloride. We know from our HX chemistry this is going to form a carbocation intermediate, And we know when we form a carbocation, we need to think rearrangement. Okay, so before we've even done anything on this problem, we know at the end of the second step we're going to have a ketone or an aldehyde. We know at the end of the third step we're going to have an alkene. And we know at the end of this we're going to have some sort of alkyl chloride, and that we may need to worry about rearrangement. Okay, now let's look at the molecule itself. When we add acid and water to any ester, we turn that ester into a carboxylic acid and an alcohol. So the key thing in the first step is that we're going to break that bond. And again, let's number all the atoms so that we don't lose anything. Right? So after the first step, there's our carboxylic acid and alcohol. And again, we can number this out. Right, now we're going to react this with PCC. Right, we can't oxidize a carboxylic acid any further. Right, we're just going to oxidize the primary alcohol so that we end up with an aldehyde. So we have an aldehyde and an acid. The Wittig reagent only reacts with ketones and aldehydes. So when we do the reaction with the Wittig reagent, that's only going to react with carbon 5, so that's going to give us an alkene. We've added a carbon, right? And again, that carbon is that one right there. That's carbon 7. All right, so that makes sense. We're keeping track of all of our carbons. Now we're going to add HCl. Let's be careful about what's happening here because we already said we need to think rearrangement. So if we don't draw out that carbocation intermediate, we're definitely not going to see the rearrangement. So let's just draw that out if the rearrangement is possible. All right, so we're going to get sorry, I messed up the numbering order here. Let me just switch that. 5, 6, 5, 6, and 7. All right, so if we add the H to carbon 7 to get the more stable carbocation, we get a carbocation at carbon 5. That's a secondary carbocation. All right, we know we're not going to rearrange to carbon 7. That would be a primary carbocation. But if we think about rearranging to carbon 4, we can do a hydride shift. Let's see what happens there if we do a hydride shift. Then we would go from a secondary carbocation to a tertiary carbocation. Right, that clearly is more favorable, more stable. So that hydride shift is going to occur. Right, this is going to be more stable. This is going to be less stable. Right, and then in the final step, Cl- can add to that carbocation. And there's our final product. All right, so just working our way methodically through this, very clearly recognizing what the reagents tell us before we start proceeding into the reaction, and then just working through it very methodically, knowing what reagents we have and what reactions are possible.